All right, let's see if we can get started. We need some music in here too. No music. Let's try again. Here we go. Let's see if we can find some synthwave from Streambeats. Right, we have this one. We have this one. I think this one will work. Today, I'm going to try something I've not really done before. And it's a little bit scary, so bear with me. Let's see. That one is running, and this one is running. All right. I wonder if I can do this. Maybe this. Yeah, let's do this one. All right. So before we get started, I thought I would do some quick introductions. So today, like in the stream before, we have been building a PowerShell module, and I have built a... Where's that music? Come on, music. Ah, there we go. Please tell me if it's too loud or too low. So we built a Tesla PowerShell module. We've used that PowerShell module to build a Tesla service. The Tesla service is a serverless Azure function that runs our PowerShell code. And it has an orchestration that when I trigger it, it will make sure my car has a comfortable and nice temperature. Today, I'm going to try to put this thing together. See if I can see the camera. So in here, I have a little chip. See if you, oops, sorry. See if you can see it. Yeah, a little bit dark. There we go. So this thingy is an ESP32. It's a small microcontroller and it's powered by USB. So I've connected the power output from this one. So it's ground and 3 volts, I think, to this breadboard. So these lines will give me ground and power. And then I have connected a little LED to ground here and to one of the pins down here on the board. And I've connected another pin to a little button. And that button goes all the way over here to power. Or, yeah, to power. So the plan here is to connect this to my computer through USB. Let's see, here we go. Have this thing boot up. And then we're gonna put some C++ code on it. And when it boots up, I'm hoping it will connect to a Wi-Fi. And when we press the button, it should start the climate control orchestration on my Tesla. If it all works, I'm gonna buy a cool button, you know, with the airplane switch thingy, so I have a lid I can open up and press, and I'm gonna put it in a small box, and I'm gonna mount it on the wall just beside the door, so I can just press it, and minutes later my car will be warm or cold or whatever I want it to be, depending on the outside temperature. Sounds good? Let's get started. I'm psyched and a little bit scared. So please let me know in the chat if you can, if you can hear me good and if the music is at a good level. See if I have everything. I also need an app here somewhere. let's have my phone app ready so we can follow and see what happens. There we go. That should hopefully work. Still no response in chat. Please, can someone just confirm that you can hear me good, and I'll be super happy. So this is Visual Studio Code. I have installed a plugin called Platform.io. I've not really used this before, so but it seems promising. So it has this, let's see if I have, here's the home thingy. So I can go here and I can basically create a new project. It lets me choose which kind of board I have, and it has some library control stuff. So it basically gave me a clear project, this folder structure over here. And I have this main.cpp. This is my code that I'm going to run. And I also got this ini file, which was pre-configured with the board I have. So the drivers I chose basically. And then I have added upload speed and monitor speed of 115,200 baud, I think it is, because I read somewhere that that was good. I'm not sure if that is needed. And I've added two library dependencies here, which are a Wi-Fi manager and an Arduino JSON thingy. I'm not sure if we're going to get to that, but that's what I have so far. So where to start? Let's see if we can connect to Wi-Fi. Oh, Ghost Quest 101, thank you for following. Welcome. So this setup thingy, I think we need to start with, we need a Wi-Fi connection. So let's see if we can get that working. And I've been reading quite a bit. Let's see, I think I have a browser here somewhere with some documentation. I think it's not that one. Let's see if we can get this on the right screen. There we go. So this seems like a super simple way to start by using Wi-Fi. There's an example here, or a bunch of examples I've found, but they're fairly complex. And there is this library called Wi-Fi Manager that helps us do this. And I'm a bit torn. I've spent like 10 hours last week trying to learn the basics of this and trying to learn the basics of C++. To be honest, don't really know what I'm doing. So it's a bit of a guessing game, but let's get started, or let's try it out. So I think we'll just start with this Wi-Fi thingy, because there is this Wi-Fi class that is included, and it seems to be working. So let's see if we can go here and include that. So I think I can do just include, and then say Wi-Fi.h. That should just bring in the Wi-Fi dependency library, whatever. And then we need to save the Wi-Fi information. In the future, my plan is to have like a small web portal. So like when the button boots up, it's going to start a web server, and you can connect to it as an access point and sign into the web server and like say, this is my Wi-Fi and this is my password and here is my my function that I'm going to call and so on. But I think we're just going to do a actually char. So if I have understood this correctly, we can do this and call it something and give it like this. So I've set up test Wi-Fi just for this purpose. I think to do like this, and we need a constant char. So if I've understood this correctly, this is just a way to set up two strings that are basically read-only. Wi-Fi password. And this is super bad practice to hard code this into. If I can bring up the chat. There we go. This is super bad practice to hard code this into. Oh, we need a semicolons. I always forget that. Here we go. Super bad practice to hard code this into the code. It's not going to be like that once we're done. But for now, let's do this. I also have my Azure function running locally here. So I have this function here that I'm going to call. So I'm thinking that we can save that here somewhere too, maybe, while we're remembering it. So this, I think, creates some kind of global variables, like API URL or something, equals HTTP colon my IP address. I think I have this IP address, maybe, colon, what was it, 7071 / prepare takeoff. Takeoff. So that should hopefully be right. With a semicolon. So here is some hard-coded strings, and then we have two functions that comes with the project. There's a setup function and a loop function. This code will basically run once as soon as the project starts up, and the loop function will run continuously in the loop until we turn it off. All right. So I think this should do the trick. And we need to have this here and this here. And then there should be like a Wi-Fi status thingy. Yeah, here. So, oops. So while this is not connected, sleep for 1 second and print. Also, we need to initialize this serial. So I think there is serial.begin, and we give it a baud rate, which is 115200. There we go. So this will just initialize the serial communication and say that we're going to use the this baud rate for communicating between the computer and the controller. Wonder if that was all. I think so. Let's see what we had. I took some notes here before we start off. Yeah, so that should connect us to the Wi-Fi, and maybe we should just yeah, here they have some scanning networks and setup stuff. Maybe we should just steal this whole thing. Oh, we'll keep it like this to start with. So let's do some serial printing. There is this println, and we can print something like starting. Here we go, and then we should connect to Wi-Fi, and then we should say waiting for Wi-Fi here, and this is a continuous loop, so it will just wait forever, which is going to be bad in the long run, but it's good for starters. And then we just do serial.println saying connected, like that. And then we start a loop. And just to make sure that this loop thingy works, I have an LED. So let's try to turn that on. I think I wrote down the pin I used here somewhere. So if I remember correctly, that pin is number 13. So I think we can do like an integer constant status led maybe equals 13. And then we can do like int constant button pin equals, and I think that was 27. I'm a little bit unsure which of these pins I'm going to use and what they are good for and so on. I think there are a few of them that have like some advanced features, but to start with, I'm just going to run with the two ones that were in the bottom left corner of the card. And we'll see where it gets us. I think I have the right numbers. So something like that. This should probably be up there. We have a password and we do this and then we connect and then we do like oh, I also think we have to set up the pins for output. Let's Google that because I forgot how to do it. So ESP32 pin set output. Maybe. Yeah, this is how I do it. Come on, there we go. So let's say pin mode and do the status LED. That should be output. And then we do pin mode button. Come on. Pin, and that should be input, I guess. Input. So this just tells the ship to like use this pin for sending information and use the other pin for receiving information. And then we should be able to write digital write maybe. Yeah. So we need to digital write the pin, which is the status LED. And it should have high, I think. So that should just turn the LED on. And then we could do like delay half a second maybe. And then we just do the same thing again. That didn't work. Let's copy this thingy, put it here, and do low. So turn it on, wait half a second, turn it off, wait half a second. All right, and let's see if we can build this. Exciting. Still no chat messages. I would be very grateful if someone would be able to confirm that you can hear me and that the sound is good. I have failed on that before. Okay, error. Let's see what it said. Update.h, no file or directory in Wi-Fi. Oh, so that's the thing I included here. Wonder if we can comment this out. Whoops. semicolons. So I just put these in here to remember them. I don't think we need them yet. Let's do a new try. Build. Not my day. Let's try again. Let's use this button instead. It's building. All right. Seems to be working so far. I hope we can ignore that one. This was insanely slow. Let's make sure I have the Wi-Fi running. Yep. Here we go. Connected. So now we should be able to do the upload button, and that should hopefully connect to my card. There we go. And then I have to press this button on the card to enable flashing. And now we're transferring the program to the card. Let's see if I can see the camera here. Here we go. Super slow. So boring. And then I should be able to, look at this. It's blinking. Nice. So I should be able to press this thingy. Okay. Here we go. Let's restart the ship again. So there's a little reset button here. And it starts. It tries to connect to Wi-Fi, and it's connected. Let's try it again. Starts. Didn't work. Let's restart again. All right. So we probably need to do the scan for Wi-Fi stuff to get a more reliant or reliable connection. Let's try it out. So, oh, that's a bright light. I wonder if I can turn it off like this. There we go. So let's look at this Wi-Fi library. here was a tutorial. So in this case, they still have the same like character array, and then they have a translate encryption type, which is just a translate from a Wi-Fi auth mode, and it returns a string. All right. Not sure if we need that, but let's start with just copying that and see what happens. So we're gonna put this. Well, actually, I think we can put this in a separate file, maybe. Let's try that. So let's do, come on. Should be able to do this whole thing. And put it in here. Copy and pasting code from the internet. That I'm good at. And then we can take this part. Maybe. And put that. Let's remove it and put it in our main thingy set up here. So let's comment this out and try that instead. All right. And then we go back here and see if we can just cut this out and define stuff in here. So here we have, don't think we need those. We have the scan networks function. It's gonna format this so it's gonna be a bit easy to read. So it says scan networks, and then we're gonna print number of networks, and they're gonna loop through the networks and print them. And they're actually only using this to write out the encryption description. All right. And then connect is. So this is actually just doing the same thing. The only difference is this part. Let's try this and see if that is more robust. And just ignore that. And I guess we can, let's just delete this file. Oops. Let's try that. I'm going to, so this should build and deploy it, I hope. Yep, seems to do something. So let's leave that for a while. And while we're waiting for that, I have also searched for this HTTP, where were we? Here. So this should be an HTTP client and should be included in the Espressif SDK thingy, which I think I get access to by including this Arduino.h. Oh, it's done. Let's connect. Button. There we go. And I'm going to put this cable back together to power the LED. And we'll see what happens in a little while. While that's working, let's put this. I have a little bit of a small desk here. We should look at this. So here is an example of a HTTP client. And I think that's the ESP HTTP client. I wonder if that was the one I was planning on using. Let's see if I can find my notes here somewhere. So I think there was this HTTP client.h. Let's see, include HTTP. Here we go. So if we include that, and I think I took some notes on how to use it here somewhere. Yeah. So I wonder, maybe we should put that in a function. So let's do like, oops, void invoke web request. And that should probably take a string, which is a URI, or we call it URI. What do we more need? So we're going to, I wonder if there is, I think there is a HTTP, probably not. Let's just do it like this to start with, and we can improve it when we get there. So I think we had this web client that we could call begin on, if I remember correctly. So it's called HTTP. No? Begin. I think this was how you did it. Let's leave that for a while. Meanwhile, we have so now we can see down here that we are starting. We're waiting for Wi-Fi, and we print out the MAC address and the IP address, and we say connected, and the blue LED is blinking down here. So far it seems to be working. Let's try to build a new part. See if we can get this Wi-Fi library in here. Or sorry, the HTTP library in here. HTTP was not declared in this scope. Oh yeah. So we need to create the client first, probably. That's how we do it. So this should maybe let's try that again. So that creates an HTTP client and calls begin on it. I think. Begin, we need a Wi-Fi client. Let's go to our friend Google. And do ESP32 HTTP client posts. Perfect. Let's do that. Prerequisites. They're using Arduino JSON to parse JSON. We need an API. We have that. We need some code. Include HTTP client. We need a server name. We have that. We need a Wi-Fi connection. Creating a client. Then they are building a URI. They are calling begin with the URI. Makes sense. So I think we could just say API URL dot C string, I think. Constant char. Oh, there is it's already a constant char. No? How did they do it? Convert it to, I guess that's constant string. And up here they have a string. All right. What happens if I do string? Oops. Okay, that works. So apparently we can't do a constant string, but a string works, and then we convert the string to a C string thingy. Let's look at this thing again. So they had a string up here, and they had a string down here, and they do .c string. All right, fair enough. And this seems to be working. Cool. So let's continue. So this is using an HTTP GET. We're going to do a post. I do not want a free ebook. Here we go, posts. HTTP begin. They're using. Let's skip that and do. Yeah, we probably need this one. So let's add a header and said we want the content type to be URL encoded for. That's good enough. And then we need some request data, and we're just gonna say this equals some value, because We don't need a body to this call at the moment. And then we're going to do this. All right, fair enough. And I guess the HTTP response code should be 200 something. Yeah, let's just print the code and call the end method. And that should hopefully clean up the whole thingy. And come to think about it, we should probably use this instead. That seems to be a little bit... Yeah, I think that should be working. Let's try it out. So we need to take this, and when we are connected, we should check if the button is pressed. If digital read. Did we call it button pin? Yep. If button pin, I think it's high if it's pressed, because it's connected to the positive part of the battery. Oh, it's doing like that. Let's try this. And just do digital. No, let's do serial print and say something. Button pressed. That and else. We do this. Actually, we can do this, and we do like I don't know, 100 and 100. Else, I'm just going to do lid high. Let's try that and see what happens. Just to make sure I'm thinking this right. So on every loop, check if the button is pressed. If it's pressed, write a message and blink the LED. And while it's pressed, it should like blink continuously. I hope. Here we go. Uploading, connecting, pressing the button. Let's make sure I have everything connected. Yeah. And waiting. Using serial communication over USB is apparently really slow. Here we go. So we need to... Oh, it's doing the monitor, good. Okay, that didn't work. Let's reset this again. So it's starting. It's waiting for Wi-Fi. Come on, connect. That didn't help. I need to figure out some way to make this work every time. Let's restart again. Starting, waiting for Wi-Fi. Okay. So that didn't work. Let's see if we can exit out of this thingy. I wonder. So, oh yeah, I probably get something. I need to see if it is high. There should be a faster way to like build and repeat this. While we're doing that, why not try to prepare the other stuff, which is invoke web request with a string. So basically we should say button pressed, we should blink this, and then we should do invoke web request and just give it the API URL like this. Save it. Oh, now it's connecting. Let's press the button and wait for it to upload. Takes a while. So let's go back to code. What else can we do in this function? We should probably take the body. String body. And maybe do this. And then something tells me that didn't work. Oh, maybe. Let's try to... So it's waiting for Wi-Fi. Too impatient for this. Restart. Come on. Waiting for Wi-Fi. Let's make sure. Button pressed. Okay, that didn't work. What if I... So if I connect the button to the minus part of the battery, see if you can see this in the camera. So if I move it to ground and I press it, then it says it's not pressed. and I release it, and it says it pressed. Which is kind of weird. So high don't seem to be working, but connecting it to ground seems to be working, although in reverse. So I'm quite confident that if we change this and saying if the button pin is low, low means pressed. Then we should do this, and we should also send in a HTTP, let's do body or whatever. And then we need to define a body. Let's do Pascal case everywhere. Up here somewhere we have our API URL, and then a string body equals to test equals some value. Oops. String. So we have URI, we have a test. We don't need that anymore because that gets from there. And in here we do like, if this is low, the button is pressed. Blink it. And let's turn the LED off if it's not pressed. Let's try it out. And let's see if we can get our Tesla app going while we're waiting. This one is connecting, so I'm going to press the button on the ship. Come on, there we go. It's writing stuff. I hope I have my phone set up here. We'll see. Encoder overloaded. That kind of sucks. I have a bunch of dropped frames. Start recording. And okay, so this is a picture of my phone screen, and hopefully I've had some problems with the cell connection on the Tesla. So if we're unlucky, we will not be able to wake up the car. And if we can't wake up the car, we won't be able to do something with the car, which kind of sucks. Then I have to go over to the car and actually start it up. But I got a new software update like yesterday, and then I installed that, and then this problem started. And then I got a new one, a software update pending, like a day later. So maybe there's a bug, I don't know. Let's see if we can get this serial monitor to start up. There we go. And see if we can wake up the car. Come on, car, wake up. So we're waiting for Wi-Fi. Hope I still have Wi-Fi connected. Yeah, it seems to be online. Okay, let's reset the ship and see what happens. Starting. Waiting for Wi-Fi. Button pressed. That was not what I intended. Ah! It starts to function. That is awesome. Although it calls the function over and over again. And it doesn't seem to adhere to my pressing. Response code -11. See if I hold the button down. Okay, so it says button pressed all the time. Let's try this. Maybe it should be high anyway. Yeah, when I release it. So let's see if we can clean this up and make it actually working. So I think I can stop the function host by doing some mashing of Control-C in here, hopefully, maybe. And then we can power down the ship maybe, because I don't want it to. There we go. And this should probably be high then. I thought we tried high first and that didn't work. We'll see what happens. There we go. Yeah, let's try that out. And we should. Yep, that's running. And I have my function code here, I think. Come on, where is the function? Maybe it's on the other screen. There we are. Here we go. So this is the code for my function API. And we need to do an Azurite. Close. This is the storage emulator that emulates Azure Storage. And then we could do clean to remove all the jobs. Queue error not permitted. Let's kill this one just to make sure. Queue service operation not permitted. This happens sometimes. It's a bit annoying. CD Tesla service. Here we go. And let's do it recursively and force. That should do the trick, I think. And when we're here, oops, sorry, we need to do the other window, which I closed because I'm. Well, so let's start up the function project again. And once we're in here, we should be able to start the Azurite storage emulator. And hopefully that should start up anytime now. maybe. There we go. So we can see down here that it should be running. My poor computer is working overtime. There we go. Service started successfully and we have all these files back again. Awesome. So now we should be able to I think they are running successfully. I just think I started too many times. Yeah. We'll see. So let's do func start here. That should start the function service in a local debug mode, hopefully. Yep, that's running. Let's put that over here and let's yeah, so apparently the car is offline and we won't be able to connect to it. That kind of sucks. But we can at least see what we are triggering the API, even though the API won't be able to talk to the car. And then we go to our button code over here. And we're going to deploy that. And we're going to put these up. See if we can find the right cord. Connect it to the ship. Let's close out these and make sure we're actually building it and deploying it again. Building. Yeah, and once I get this working somewhat okay, I'm going to see if I can get this Wi-Fi manager working so we can get a bit more robust Wi-Fi. That should be flashing, good. And I'm thinking of doing some kind of task for the LEDs so I can get like a different blinking pattern depending on where we are in the app, because obviously I won't be able to connect this to a computer while it's on the wall. But I'm fairly confident that we can make this work. Oh yeah, we accidentally triggered this once when I connected the button, and so hopefully it would start up, connect to Wi-Fi, and do stuff. Serial monitor. Starting. Waiting for Wi-Fi. Connected, and button isn't pressed. What if I hold the button down? It says the button is pressed. If I release the button, it's pressed. If I connect it to ground, it's pressed. If I actually press it, something's wrong. Okay, anyway, we have an HTTP client working. We can call the function. We can trigger stuff. It obviously runs stuff in here. Although I somehow failed on the button part. So it's just gonna call my function all the time. I guess that's something I have to fix. But otherwise than that, it seems like this is actually possible. So I'll do some more studying and hopefully I'll see you here next Monday. Until then, take care. Bye bye.